Hi everyone, my name is Brandy Bell and I would like to welcome you to another webinar hosted by Premier's Data Alliance Collaborative. Our topic today is optimizing performance in Netezza and is the third webinar in our Netezza Deep Dive series. We'll be continuing this series offline with a presentation entitled Creating and Managing Databases, Tables, and Security, which will be posted to our BI Community of Practice on Premier Connect. Be sure to provide any comments or ask questions about this material in a Premier Connect discussion post so that Rush can address them. Also, immediately following the webinar, you'll be prompted to answer a few quick questions about your experience. We truly appreciate your feedback and thank you in advance. For those of you who are not familiar, today's speaker is Rush Shah. He is a Senior Solution Architect of Premier. Rush has been working in the BI space for over 13 years within multiple industries. He specializes in Oracle, SQL Server Analysis Services, MicroStrategy, Netezza, and Cognos. I will now hand over the presentation to Rush.
Thanks, Brandy. So we're going to start with optimizing performance in Netezza. Some of the stuff that we will be talking today, you will hear highlights of what we've talked in the first two sessions, obviously. There will be a lot of repetition from the last session, especially to give you context, but I have been warned that we need to finish as much as possible today, so or we need to finish the entire deck, and that is one of the reasons we sort of separated the creating and managing databases and security section into an offline content. So you'll be able to leverage that, and we also plan to actually do an offline session on Hadoop again so that I'm not hurried and can elaborate on some of those concepts and how we actually use them in our day-to-day life. So with that in mind, I'll start today's presentation. We've talked about performance in Netezza from two different perspectives in our last session. We talked about the idea of distribution, and we've talked about the idea of organizing data. So distributing data and organizing data are two main ways that we can impact performance in Netezza. Now, organizing data can be done in several ways. Obviously, the associated concepts with organizing data are zone mapping our data, right? And the zone maps that are automatically generated by Netezza can be enhanced and leveraged in different ways by materialized views and cluster-based tables. You can always improve your zone maps by generating stats manually. You can also groom your tables in order to ensure that the multi-versioning concurrency control that Netezza automatically has is optimally used. So that's why we are basically focusing on the 5 concepts that we've already talked about last time. The additional thing that we are going to do this time is walk through scenarios and walk through the interpretation of your query by the Netezza optimizer, right? So those are the things that we want to talk about. Of course, it begs me to actually, re-explain some of these concepts. I'm going to do it very quickly so that some of you who have participated in session 2 and session 1 are not going to get bored. But I do want to sort of highlight the main topics of conversation around this distribution and collocation, right? We know distribution is a way of storing data in data disks or data slices in Netezza, but the main purpose of distribution is to enable parallel and massively parallel computing, right? And that happens only if we have collocation of data. Distributing one table is not enough, right? It is the distribution of 2 or more tables on the same column, on the same hash value, not even the same column, but the same hash value, that will ultimately allow us to gain performance or drive performance in Netezza. We know that a table exists only once in the Netezza catalog, right? It's sort of like a Platonic entity, right? A table is like a Platonic entity. It's just existing once in the catalog. It's completely abstract. Its physical existence is instantiated into as many disks as it is distributed in, right? A Netezza table can be distributed in multiple spools or will be distributed in as many spools as possible, depending on the distribution key you are using or distribution column you are using. So queries by the Netezza optimizer, or the compiler rather, I'm sorry, a compiler are compiled into as many snippets as there are spoos available, or as there are spoos on which data is distributed, right? This is your typical Netezza architecture. Single instruction, multiple data architecture is how they refer to it. We want to be cognizant of it because we want to take advantage of as many spoos as possible. At any given moment in Netezza, we know that our query is going to return data as fast as the slowest spool, right? So we want to make sure that we have distributed the data correctly and we get the advantage of all the spoos, but if one spool is slow, our query will be assembled according to the speed of the slowest spool because of the massively parallel computing architecture, the way the distributed architecture of Netezza works, right? We want all the spools working together. That's the entire idea of distribution and collocation. Collocation is the distribution of two or more tables on the same spool or the same disk or the same hard disk in a spool, right? If the fact and dimension tables are distributed on the same column, then Netezza will hash the column values and store all the data on the same spool based on that hash value. Now keep in mind, we already have discussed this, I suppose, a number of times. Netezza does not care for indexes, partitions, and therefore it does not care for any constraints that are typical to an RDBMS environment. Netezza only observes two constraints, right? The default value constraint in a table and the not null constraint. All other constraints are merely informational from a Netezza standpoint. So if you think that you need to distribute on a primary key or any kind of surrogate key, well, all of those constraints that come with surrogate key of primary key, foreign key, or dimensional key, or however you name them, they are not going to be observed by Netezza. What Netezza really cares for is hashing the values and storing the data. So all the other things are immaterial. It is of course advisable that you use in your DDL that kind of redundant phrasing. You can always use the redundant phrasing in your DDL for primary keys and foreign keys, for example, and any other constraints that you want to put into your DDL. Knowing fully well that they are merely for third-party integration, they are merely for a proper understanding of how the tables are associated with each other. Netezza itself will not care for them. Having said that, it's still advisable that we use integer columns for our distribution key, right? Because that way Netezza can hash the values, and that will be more useful for computing. Computing is always better on integer columns as such. We know syntactically speaking how distribution occurs. It's very simple. All you're doing is adding a distribute on clause. If you do not add a distribute on clause in your DDL, what will Netezza do? It'll do a round robin distribution. We know this, right? We've talked about this too. We've also talked about, in some sense, data skew and process skew. We know that data skew occurs when data is not distributed evenly on all spools. And this is a very typical scenario with low cardinality, mini dimensions, and a very typical scenario with Boolean type data type, Boolean columns or Boolean data type columns, right? So if you have distributed a table on a surrogate key associated to a mini dimension table, let us say a mini dimension table like patient class, which only has two values, inpatient and outpatient, or encounter type, which may have 30 or 40 values. That's a mini dimension table from a Netezza perspective. When you do that kind of stuff, it's really low cardinality column. Netezza will not end up spreading data on all the available spools. Let's take a typical example of 80 spools in a Netezza box, right? If you have only 40 values, you're only utilizing 40 spools. 40 other spools are not being utilized for data storage, or for that matter, after the fact for data processing. So what we have is a data skew, and this is bad because we are not utilizing all the spools in the box to allow us to do massively parallel processing, right? So you want to do this kind of distributed computing on all your different spools. That's not occurring in this case. So that's bad. Process skew is also bad, and process skew will inevitably occur when there is data skew, but it can also occur when data is distributed on all spools and it's distributed evenly, but it's based on columns that are not stored on all spools, right? So when can this happen? I think the most typical scenario we see about this, about process skew, happens when you distribute a table on a date data type column, right? So let's say you distribute a table on either the encounter contact date or discharge date or admit date, something like that. What will happen is typically your queries will only query data for 6 months, maybe 10 quarters or 3 years or 2 years. Those are the kind of queries you'll be shooting. So there'll be data for all the other years that will never be queried and that may live in spools that will never be touched. So you got this entire process skew where only a few spools are working for your query because you've distributed your query based on date columns, right? So it's possible that date columns may cause this kind of a process skew, and we want to avoid it in order to drive performance in Netezza. We want to use Netezza the way it is supposed to be used, and that's part of the reason we want to avoid process skew. There are other things that we want to avoid, and there are other concepts that we want to learn in Netezza, that what happens behind the scenes under the hood in Netezza, right? So mini dimension tables, we talk about it all the time. In data warehousing, a lot of people tend to create these kind of mini dimension tables. I personally recommend never to have them. You should have a strategy for junk dimensions, and if you do not, that's bad. I'm not going to go into data warehousing theory on what a junk dimension is, but many mini dimension tables can be combined to create a junk dimension. The mechanics we'll leave for another day. But if you have many dimension tables, or if Netezza encounters very few values that need to be used from a dimension table, it will choose to broadcast it because there is very minimal cost involved with it. So the Netezza optimizer will do cost-based optimization of your query, and it will say, I'm only selecting 20 rows from a table of 2,000 rows. Let me just broadcast those 20 rows, right? As long as they are in the where clause, there is something that filters that table down to 20 rows. Netezza will just broadcast it. Even if you have a table with just 30, 40 values, like your encounter type dimension, Netezza will broadcast it. It will say, okay, I don't really want to incur the cost of understanding what's going on with this table. Let's just broadcast it to all the 80 spools that I have in my appliance, and let the joins occur after that broadcasting process, right? So we'll see today a query that does that. Single redistribution occurs when it is not possible to distribute both tables on one relationship key or one join key. In this case, Netezza will redistribute the needed columns to other disks or data slices, right? This will very often happen because the strategy that we are going to recommend is to distribute your data warehouse on keys that are used in multiple fact tables. Surrogate keys that are present in multiple fact tables is our key strategy of distribution in data warehouses. So if we recommend that, then we also automatically know that redistributions will occur for all the dimension type tables that are in your join scheme in your query. And we'll see a case of that too. We'll see a lot of redistributions occurring because of dimension keys not being used, or dimension keys are not used. Not all dimension keys are used for your distribution strategy. Double redistribution will occur if neither table of the join is distributed on the join key, and this probably can be dangerous when you have two fact tables and they both are distributed on a key that is not a part of your join key, right? So double redistribution definitely want to avoid, especially when it comes to two fact tables, right? We've talked about this. We also have talked about what is good distribution, and I'm just reiterating some of these things because these are important. Good distribution is always something that drives maximum co-located processing and maximum co-located data placement. We talked about the fact that distributions are not similar to partition, and the key difference to partitioning and distribution is co-located processing and co-located data placement. Even when in a database like DB2, for example, you do database partitioning as well as table partitioning to kind of enable distributed processing, even then it will not ensure co-located placement and processing, even when you do database partitioning along with table partitioning. So that's the key difference that distribution brings to partitioning. That's the difference that happens. Good distribution is always based on high cardinality integer columns that are frequently used in joins. You can use, of course, 4 columns, but we recommend you use 1 or 2, no more than that. We also recommend that a good distribution strategy is not sufficient, that if you have analytical type tables, use CTAS. Don't rely on your data warehouses, transactional fact tables, and dimensional tables to give you performance. Use CTAS. They're very, very useful. Use create table as is what I'm saying. And we have a whole section on CTAS in our creating and managing databases and tables and security slide deck that has been uploaded to the deck community. So definitely go and grab that, because that will kind of give you the best practices around CTAS and why we really enjoy having using CTAS. Bad distribution obviously is everything that good distribution is not, but more specifically Boolean keys, data type keys that are being used for distribution, surrogate keys of many dimension tables, and multiple surrogate keys. Right, we've talked about this. Let's now go into scenarios, right, for distributions, because this will quickly give you an idea. Conceptually, if you look at the encounter subject area and if you look at this conceptual model of that, right, this is very intuitively understandable for anybody who deals with healthcare provider data model. All of us in the Data Alliance community speak the lingua franca of IBM joint data model that was created between IBM and Premier. We all borrow and enhance our data models from that data model that we have already, that we commonly share, right? So this conceptual model should not be a surprise to anyone. What would happen if we have this model and if we take the encounter table and we distribute it on 3 columns? Right? We distribute it on provider SK, patient SK, and diagnosis SK, thinking that, oh, because I habitually join my table, encounter table, to these 3 dimension tables, patient dimension, diagnosis dimension, and provider dimension, let's distribute it on that. Well, this will, if you pursue this kind of thinking, that this is how I join it to the dimension tables, if you pursue that kind of thinking, you will actually hash value based on 3 columns, and you will distribute your encounter table based on these 3 columns combined. This can cause massive problems because you're not distributing your provider dimension table on these 3 columns. You're not distributing your patient dimension table on these 3 columns. These 3 columns don't even exist in your patient dimension table, right? So what happens is the dimension tables on one hand are distributed on just 1 key, whereas, or potentially on just 1 key, whereas your encounter table is potentially distributed on these 3 keys, at least in this scenario, right? So this will cause massive amount of distribution on all 3 dimension tables. Now, it may not bother us if diagnosis dimension, right now, what ICD-9 is what? 9, 10, 12,000 rows, maybe 14,000. ICD-10 is 140,000. Provider SK is, I don't know, care provider table, maybe not a very big table. 2,000-3,000 physicians, maybe if you have nurse practitioners in it, probably more. Still not heavy, but patient dimension definitely will go into millions, and that is going to cost you. So that's why we always recommend to restrict your distribution to a single key, right? You don't want to, or 2 keys. where absolutely necessary, and we'll go through a scenario where it's necessary, right? Second scenario, we've talked about distribution on high cardinality columns. Again, the conceptual model we are looking at, borrowed from the IVM JDM model, and again, something that we are all using, this conceptual model in some sense. In this case, we have three big fact tables, right? We have lab results fact table, we have specimen collection fact table, and encounter fact table in our data warehouse. We have lab results fact table distributed on lab results surrogate key because we like to use high cardinality columns. We have encounter fact table distributed on encounter surrogate key, and we have specimen collection fact table distributed on specimen collection surrogate key. Each SK, of course, represents a unique record for that fact table. What will happen to this query if we are joining all of these three tables, which we inevitably do if we are doing any kind of antibiotic cohorting, right? Those of you who are familiar with antibiotic cohorting know that this will happen. These three massive fact tables are joined in antibiotic cohorting. And they are joined not on one and the same column. They are actually joined on different SKs. You're joining lab results to specimen collection on specimen SK, and you are joining encounter to specimen table or lab results table. However you choose to do your join scheme, you can join it on encounter SK, right? So you have two different ways of joining three different fact tables, right? And they don't have any commonality, so you will have massive amounts of redistribution, at least double redistributions. And I kid you not, when you do this on lab result SK, you will cry because you distributed your lab result fact table on lab result SK, which is never used in any join scheme. It's totally futile to distribute lab results on lab result SK. And yet we can make that kind of a fatal mistake when we think about high cardinality columns and saying, okay, let me take this high cardinality column and just distribute my table on it. Find a common connector between these three fact tables. In fact, I say if you have a data warehouse of multiple fact tables, it behooves on all of us to find a common connector between all the fact tables, if possible, right? And try to distribute on a column which is in all of these fact tables. In fact, I will go one step further and state that if you do not have a common connector, if you only have encounter SK as a common connector and you did not choose to persist patient SK in lab results table because you said, okay, you anyways need to go to encounter to query your patient information and via the encounter table go to the patient dimension table, I would say it's a bad strategy. I know that was a mouthful there. But what I'm trying to say is persist columns in the fact tables, common columns in the fact tables if they are not necessary. Be even more redundant than the Kimball methodology asks you to. Netezza loves this kind of redundancy, and it can be then leveraged for distribution. So persist patient SK if it doesn't exist in all these fact tables. And the distribution strategy, of course, I'm saying here, the valid distribution strategy would be to either select encounter SK or patient SK. Distribution on a date key. What will happen to queries in the encounter subject area model if the encounter table were to be distributed on a date key, something like a contact date key or encounter date key, right? Here it's based on a lower cardinality column. Calendar dimension with 200 years worth of data, at least in the premier data warehouse, is no greater than a 60,000, actually it's 70,000 records when I last checked. The problem here is if you're querying for 2-3 years worth of data, you may not be using the spoos on which the rest of the historical data is distributed and stored. Not only will this result into data and process skew, it may also cause redistribution of large dimension tables like patient table, right? Because you didn't consider patient dimension or encounter dimension. We have a junk dimension called encounter dimension. You didn't consider those kind of dimension tables for distribution, right? So never distribute on date, as just re-emphasizing that point, including date SK, which is an integer data type. but it's still a lower cardinality column. Distributions also need to be understood in terms of Windows SQL functions. Windows SQL functions or window functions in SQL are very useful in healthcare. We know this because we do this all the time. When it comes to drug usage, when it comes to organism acquisition rates and stuff like that. So anything that's associated with harm, with diagnosis, with or multiple diagnoses to be sure, with organism acquisitions, drug usage, we know we use this all the time, this kind of Windows function. And when we do, we want to actually ensure that we are using distributions, because a Windows function, if distribution is used, will perform in Netezza far better than it will ever be in Oracle, which actually invented these functions. Right? Windows functions come from an Oracle innovation, but they will perform far better in a distributed environment like Netezza if you leverage the distribution key in your Windows function. Rewrite your Windows function as is stated on the screen to redundantly include stuff. So we have a scenario here where we are doing organism acquisition rate for a hospital inpatient encounter from the lab result table, right? Now lab result table, fortunately, I was smart enough to distribute it on patient SK, surrogate key, right? So that I could join it with all my other fact tables and the patient dimension, which I inevitably always tend to use. Well, here though, I want to calculate the organism acquisition rate per the encounter, so I wrote, a spare window function to count my distinct organism SK over and partition them by encounters. And so this will give me my counts by encounter SK. Well, the problem is Netezza doesn't know that it needs to use distribution key for this, or it needs to use the distribution as such. We found this about a year ago, and we were like, why is this? Netezza seems to always perform on Windows functions so much better. And we were totally perplexed until David Birmingham pointed it out to us, or I think it was a blog by Sean Fox. I highly recommend that you guys go to the blog of these two Netezza ninjas that we have out there. They sort of do a great job in explaining some of the fine concepts. And it was there that we learned that Netezza was under the hood not really using distribution strategy at all, in spite of the fact that we implemented the right distribution. So we then redundantly included patient SK. And this is completely redundant. It has no meaning to include it, but this allowed us to improve performance in Netezza. So it's very counterintuitive, and that's why I wanted to include this scenario for you guys to kind of get your head around. Now, the scenario 5 is equally interesting because this scenario kind of gives you an idea of how data warehouses work. Data warehouses don't work on one simple way of writing queries. We have different scenarios, different kind of use cases, and therefore we have different kind of query. If we were to actually write queries to calculate ACO measures, we are typically measuring a patient over different time period and seeing if he or she passes or fails for the CMS criteria for that ACO measure. Now the patient SK, surrogate key, or the number serves as an ideal candidate for distribution if you're doing ACO measure type query. But what happens if you're doing an ARC measure? ARC measures are typically all based on encounters, right? Therefore, using encounter SK in that scenario would be justified, because even if you're going to your lab result fact table or specimen collection table, or hospital acquired condition fact tables, all these different fact tables that you have, you're doing all these things and you're going to join it on encounter table, encounter SK. Even if a billing table would have the encounter SK, so why not, right? That's what the ARC measures use for calculations all the time. So it would be a justified candidate for distribution. And then you have something like antibiotic cohorting, which is extremely important, extremely useful for your antibiograms it basically prescribes the strategy of how antibiotics need to be used by your care providers for your patient population, for your hospital's patient population. Well, here specimen SK is very useful because you're basically always concentrating yourself on the specimen collection with your lab results. So there are three different scenarios in which three different ideal candidates can be chosen, right? I want you to think in terms of a hierarchy of your data, right? Because this, to me, helps me decide how I want to distribute my fact tables. So I do have a hole in this too, so there is no absolute ideal distribution strategy anywhere. So, but you want to choose the most minimally costly strategy, right? You have to incur cost somewhere, so what would be the minimal cost incurred? In this case, I find that patient SK has always guided us, and I know I have belabored this point in the last presentation too, but this hierarchically helps you understand each patient has multiple encounters. Each encounter has multiple diagnoses. Each encounter has multiple drugs administered if they are inpatient. Or they have medication lists or problem lists. They have multiple problems. They have multiple specimens that are collected from them. They have multiple procedures that are performed on them. They have multiple lab tests that are done. So immediately we know that encounter and patient is the right strategy. And the reason we are going with patient is we are in a data warehouse environment. And a healthcare provider data model has at least, IDM model, for example, has at least 15 to 20 fact tables, and almost all of them have encounter and patient, except for tagging tables. They have only patient SKs in them. But almost all of them have, if possible, patient at the minimum. So distributing your data on patient will provide you the biggest bang for your buck, which is not to say that all your queries are now safe completely, right? And that is why we also recommend that you start using CTAs, materialized views, and cluster-based tables. That merely organizing your database around the data warehouse idea of Kimball is not sufficient. You've got to be redundant in the way you tackle how you consume your data. Right. I hope that it allows you to understand distribution, because now I'm going to move on to zone maps, and we've covered zone maps and how zone maps are internally generated system tables. They're different from indexes because unlike an index, zone maps do not know exactly where the database or where the data lives. It only knows the min and the max value of your integer data type column or integer data type columns. You have big int, small int, integer, all of those three integer data types, and your date or timestamp data type. Those are the only two columns for which Netezza internally generates system tables and maintains min and max value. Zone maps are very useful because they are applicable to your where clause in your SQL queries, and they allow you to reduce your disk scan operations, right? And we will see this scenario very soon. When a table is dropped or truncated, the system updates the zone map and removes all record associated with that table. Netezza will automatically create new zone map and refresh existing ones for each data slice or data disk when you do insert, update, and load operations on a table, or when you manually generate statistics. Zone maps will be disabled when you execute generate statistics command. In addition, you can also have zone maps on columns other than data type or integer data types. These can all be done through cluster-based tables, and you can use order by clause on materialized views also in order to do this kind of zone mapping. And all the other columns are used. I do not recommend that you do that, but you can. Cluster-based tables, we've also talked about this. Cluster-based tables are a concept that is closely associated with materialized views, and they both are under the umbrella of zone map. if you want to conceptually think about things. What they do is, again, reduce the scan operations. And remember, data warehouses are notorious for table scans, right? All the data that is included in the select clause is automatically pulled into your CPU, or it's actually more than the select clause in case of non-Netezza database systems, right? So you want to kind of reduce the scan of the entire table, reduce the scan of the width of the table, right? Your table could have 100 columns, and Netezza will bring all of those columns from the disk onto the CPU RAM so that the CPU can perform select operations on it. Well, in Netezza's case, of course, we have FPGA, which will actually reduce the width of the scan. But that width can also be very expensive when you have 100 or 200 columns in a table. So be very mindful of that kind of stuff. Cluster-based tables are concepts that allow you to cluster records on a key and store them in nearby extents on your data disk. Now, this is very useful if you've distributed data on a data type key, right? So you're querying data only for a couple of weeks or 3 weeks or 3 months or 3 years. You know your data is organized in extents which are side by side on your data disk. And this can expedite data selection. CBTs can be changed with an alter statement. So if you've created a table, created a cluster-based table, and you now don't want any clustering going on, you can make it a non-CBT table by merely using the organize on none clause. One of the disadvantages of CBTs is that it affects compression ratios in Netezza. One of the advantages of it is, unlike Materialized View, it is no additional cost is associated with CBTs. Materialized views, of course, are not allowed on cluster-based tables. So I said that they are associated or aligned concepts, so we'll come to that. Now, clustering, in another sense, if you want to think about clustering, it's automatic defragmentation of data, right? You are clustering data on side-by-side extents, so you don't have to later on defragment it, right? But Netezza has this concept of multi-versioning, right? Remember, we talked about it briefly last time, that when you do an update operation in Netezza, when you do an insert operation in Netezza, when you do a delete operation in Netezza will not physically insert, update or delete that record. It will actually create a new record and append it into the table. And internally, it will keep track of what is the latest record and give you back that record. When you do things like this, what happens is you cause fragmentation of data. And that's why you need to use Groom command. Clustering, to a certain extent, will reduce the fragmentation of data because it is manually, or it is automatically aligning your data based on a column. But it's not necessary that it's not necessary that delete operations, the fragmentation caused by delete operation and update operations, is used by. We'll go next to Groom and Generate Stats. We talked about this quite a bit, so I'm not going to belabor the point, but you have to manually sometimes groom your data, and you definitely need to manually generate your statistics for your tables, because it's very helpful for Netezza catalog to know all these values, right? So Generate Statistics will gather statistics for every table and every column of that table, and the kind of values it will gather is duplicate values, minimum values, maximum values, null values, unique values, etc., etc. So basically, frequency and dispersion of the values, the min-max of the values, the null values, right? And there are some differences between Generate Stats and Generate Stats Express. So I'll move on from that. We were hoping to actually conclude here, but we do have time to go over to Materialized View and interpretation of queries. So if nobody has any questions, we will move on to that. We'll move on to Materialized View, and this was deliberately done this way because we were not sure if we'll finish everything. So we wanted to keep Materialized View and interpretation of queries in the next phase. Now, Materialized View is, I love Materialized View. I highly recommend that you guys use this over cluster-based table, but that's just a personal bias. It does incur additional cost because it is stored again in Netezza. And to me, disk storage comes cheap, and actually it's really useful to not make Netezza scan a fact table that is 100 column wide or 200 columns wide. It's really useful to actually reduce it down into small thin slices. I do hate Chicago style pizza, so I'm sorry if I offend anybody. That's why the reference to New York style thin slices, because I do love the thin slices, and that's why also, in some sense, analogically, I love materialized views. Materialized view is a sorted projection of one and only one table. Now, this is something that people kind of trip over, right? You can't use more than one table in a materialized view, and that's why this materialized view is not the same thing as what you do in Oracle. It's very different. It's used for thin slicing a table, so you want to reduce, if you have 105 columns, you want to reduce it down to just 6 columns. It's awesome, right? You use materialized views for it. Materialized MVs or materialized views are typically sorted like the base tables, but they can be reordered, or they can be resorted the way you want. Again, this is very useful from a zone map perspective. It's very useful for your where clauses, right? And how your where clauses are performed. Essentially, materialized views are reducing your disk scans, or data scans, table scans, if you will. Right? There are some more things that you need to understand about materialized views in Netezza. They're very different from how they work in Oracle. They're user-defined, of course. That's the same thing as happens in Oracle, but they are automatically managed and automatically maintained in Netezza. What does this mean? This means that when you do any kind of a load, insert, update, delete, truncate table operation in Netezza, it will automatically get reflected in your materialized view. This is something that people do. People always have to set kind of refresh materialized view thresholds or refresh materialized view time limits. You don't have to do that in Netezza. One other thing that Netezza does is it automatically manages this materialized view. So if you send a query to your encounter table and there is a materialized view for that encounter table that only has the 6 columns that you want to use in your query, Netezza will automatically decide to use that materialized view. It will not use your encounter fact table, which is splendid because you are automatically protected by people who don't know about your materialized view, right? So if you have an encounter table and there are 2 or 3 materialized views that are implemented by different applications, and some user comes who doesn't know anything about those materialized view and queries the encounter fact table, which is 150 columns wide, well, guess what? Netezza will automatically manage these things and send it to the appropriate materialized view if possible. That's awesome. Adding MVs can be useful if Netezza database is used by multiple applications, right? So, especially if it's used by BI in a certain way and advanced analytics group in a certain way, they all should use their own materialized view just to help them and their queries. Refresh in materialized views refreshes the sort order of the data, not the data itself, right? So the sort order of the data is refreshed. Systems automatically add a column to the materialized view to define where that record lives in the base table, right? So materialized view live on top of the base tables, and the system will automatically append a system column to a materialized view to kind of reflect where the data is, where the organization is for the base table, so that you can virtualize your zone map, right? This is all about virtualizing your zone map, cluster-based tables, or not cluster-based tables, but materialized view. Load, insert, and update records will always append unsorted rows to your base table, right? So that can end up reflecting in your materialized view, and I told you there is only to a certain extent can materialized view tackle this virtualization of zone map. Because Netezza has multi-versioning of rows, you can't really take away that multi-versioning. So that will cause some fragmentation, right? And so how do we what do we do about that kind of fragmentation, right? So we do need to automatically sort of instantiate refreshes of your materialized view so that the sort order is improved or is reflective of how the data is organized. For large load operations and insert operations, in other words, large batch jobs, we do recommend that you suspend the materialized views before them, so your ETL jobs at night or intraday ETL jobs, and you refresh them. There are some restrictions, and syntactically speaking, you can look at everything. There is a whole syntax version of this, and it's very simple. As usual, Netezza is extremely simple in how it does syntaxes for all of these things. It's not as complicated as you would see it in Oracle. But there are certain restrictions of materialized views in Netezza that's very different from Oracle, in that you have to keep in mind materialized views can only be based on the base table, on one base table, and it cannot be created on external tables, it cannot be created on temporary tables or system tables or cluster-based tables. Important to remember this. Expressions cannot be used in the select columns or the projected columns. You cannot use a case statement. You cannot use calculations like average and stuff like that. That have to be performed in a query after. Materialized view must have at least one column in the select clause. No joins are allowed, of course, because it can only be based on one table, so that's really a redundant specification. Your where clause is not allowed. There is no where clause in Netezza. And there is no descending sorting in Netezza. There is no reason for it. So there is no need for descending sort. And the columns in the order by clause have to be stated in the select clause. You can't really escape that. Thin slices, obviously there are some best practices here. They imply as few columns as possible, by which I don't mean go like 2 columns or something, but try to have 15, 20 columns, not more than that, because you will defeat the purpose of having a materialized view. And this is true for all databases, not just for Netezza. They don't care for the length or how deep your table is. All databases care for how wide your table is, because that's what affects the scan operations. If you have both a wide and a deep table, it's a problem. And that's why materialized views, the way Netezza conceives it, can be very useful in traditional data warehousing, because data warehousing fact tables sometimes go crazy. At least the transactional fact tables go crazy, right? So you want to reduce the size of it. You want to include frequently queried columns in your materialized view. Obviously, that goes without saying. You want to ensure low cardinality columns in your order by clause if you are using them, right? So you want to use, I would say, data type is your best bet for organization of your data. Create few different materialized view for each fact table. So if I was there, I would distribute my encounter fact table and create a materialized view, one distributed on discharge date, or one organized on discharge date, and one organized on my admit date, and one organized on my contact date. So anybody who submits the query, the select clause of all those 3 materialized views are the same, but the order by clause are different. And Netezza will automatically understand that you created a query with a where clause on contact date as opposed to discharge date, and it will use that materialized view. And this can be very useful. It can be very powerful when you do this. Set an acceptable threshold for unsorted data, right? So I was talking about how load and insert operations will, because of Netezza's multi-versioning, because of its only logical deletes and logical updates, will create at least some fragmentation of data. And how do we solve the problem of that fragmentation? We sort it by threshold, setting thresholds. This is system-wide. You cannot set it for one single table. So always try to use acceptable threshold percentages based on your highly active fact tables, not on a slowly changing dimension tables. Periodically, on a weekly basis, manually refresh this or create a script that will refresh this tables. Date data type columns are ideal, as I said, and remember, materialized views do incur storage overhead. Right? They are incurring overhead, but I don't care. I prefer materialized views to CBTs, and I do say go ahead and incur that cost. useful. Again, this is syntactically speaking what we do with some of these things. It's really different from how you do it in Oracle, so just want to highlight that fact. Let's talk about understanding the query in the last 2-3 minutes. Or if somebody has questions, maybe I should start addressing questions. I think this section is fairly well described, so I should probably address questions if people have questions at this stage. All right, so maybe I'll take the last 2 minutes to kind of overall do the review of what this section is all about. This section kind of tries to tell you what the optimizer in Netezza is doing with your query. And Netezza optimizer is pretty invasive, right? Netezza likes to optimize your query. So it's like an editor in a publishing firm. They like to tell you where your grammatical mistakes are. They like to rewrite your expressions and phrases. Well, Netezza optimizer is pretty similar. Of course, it will take into consideration your data distribution, organization, your join orders in your queries, and whatever else you are doing in your queries, right? It will do that. And then it will make use of your zone maps and your generate stats, right? Your just-in-time statistics in Netezza. All of that is very used because Netezza's optimizer is obviously cost-based, like any optimizer in any database. So it will try to decide the best method for scanning data. It will try to decide what is your join order and what type of join method you are using. We want to be as close to a hash join as possible, and we don't want disk hash. You don't want disk hash operations, but you want these things. You want to understand these things. You want to understand how data movement is occurring between your spools and how your optimizer does those things. So what we have later on, if you go further on, is here an example of how you can actually take a query and understand its plan. Right? So Netezza gives us different ways of understanding this plan, and 3 different ways: explain verbose, explain plan graph, which is an HTML way of understanding it, and explain plan text, which is natural language description of the plan. I do like all 3 of them and use it in a different way to understand my queries. And here we are showing you how a query is joined on 3 different tables. And then we are showing you how in explain verbose, we are seeing how each node is acting on these queries. Now, unfortunately, my table is distributed on facility and encounter. Encounter table is distributed on that. And my query, if you go back, doesn't do any kind of co-located joins here. There is no other fact table that I'm including in this query. So there's only one fact table, and that's the encounter fact table. And then everything else is small dimension tables. So I don't mind if there is broadcasting happening, and you can see a spool broadcast happening. You can see that Netezza utilized my filter condition where year number is equal to 2002. So fortunately, before doing the broadcast of my calendar dimension, it actually filtered it. And then it did a scan of my encounter table. And it was a pretty big scan, 1.1 million records, I suppose, right? And they were wide enough. It actually scanned 23 columns. Not very good. I would have liked it to use materialized views, but it didn't have those materialized views. I could have improved there, right? And then you have a plan graph in which you can see how each action happened. So here, as I conclude, you can see that it's first scanning the calendar table on the CDR table. Then it's doing a hash join on facility and calendar table. Then it's doing a hash join between encountered and calendar table. Then it's doing a hash join between the output of that and the facility table. Then it's doing the grouping. Then it's doing the aggregation, and then it's materializing the query in the cache, the object cache, and then it's doing the sort, after which you get the query. The query took about 1.17 seconds. Not that worried about it, but I have stats for every single stage at this point, and I can do some improvement. How you can use your explain plans are also given here, so you can always look at this and try to understand how to actually optimize your query after you've understood your query plan. I think with that I will conclude.
Thank you, Russ. Thank you all for attending this session. This presentation recording will be made available in the Business Intelligence Community Practice on Premier Connect Data Alliance community. Also, please be sure to check out the presentation entitled Creating and Managing Databases, Tables, and Security that I referenced earlier. If you have any questions about the webinar or the material, please contact us via the email address dac_operations@premierinc.com. Also, please remember to take a moment to complete the brief survey process at the close of the webinar. Thanks again, everyone, and have a great day.
Thank you.